Warning, you're headed to Earth's core. We've packed you a shovel. Don't be afraid, dig boldly. Relax, you won't need it. You jump right in, 10 meters, 50 meters, 100 meters, falling fast in the dark. Wind screams past your ears. At 500 meters, you start sweating. The air keeps getting hotter. 15 degrees, 20 degrees, 30. Your clothes are soaked with sweat. Sweat drips into your eyes. It stings sharply. You try to slow down, but you just can't stop. You're in free fall. Falling faster and faster, your body slams the tunnel walls. Your head is spinning. 1 kilometer, you feel something hot dripping onto your head. It's water scalding, splashing your hand. So hot, you shake it off. You check the thermometer. 80 to 90 degrees. You think, isn't water supposed to boil at 1? But you look at the rock walls. The pressure is immense. 100 atmospheres. Water here needs far more heat to boil. Like a pressure cooker. You look closer. Hot water seeps from cracks in the rock. Gold flecks glimmer in it. Real gold, dissolved in the water. Iceland powers itself with water like this, saving $1 billion a year. You keep falling. 3 kilometers, bang. You slam into a jutting rock. You're flung backward. The back of your head hits the wall. You touch the back of your head. A sharp pain shoots through. This wall is granite. Terrifyingly hard. You punch it. Your fist goes numb. Not even a mark on the stone. This is the main rock of the crust. About 20 to 30 kilometers thick, covering the whole continent. Your ears suddenly ring. Something's wrong. The pain makes you scream. Warm liquid trickles from your ear. The pressure is too much. 300 atmospheres. Your eardrum can't take it. It's ruptured. 5 kilometers, nearly 200 degrees now. Like you've been thrown in an oven. Your skin burns. Every breath feels like fire. Your throat is dry as sandpaper. Your tongue starts to blister. Deeper than the world's deepest gold mine. South Africa's Impanene mine. 4 kilometers. Miners ride 40 minutes just to get there. It's 60 degrees down there. They need air conditioning, but you're pushing 200 degrees. Slowly roasting. 10,000 meters. The rock around you starts to soften. You rub your eyes. You're not imagining it. Solid rock is changing here. Still solid, but no longer brittle. It's 300 to 400 degrees here. Pressure, 100,000 atmospheres. Under conditions like this, rock turns plastic. No longer crumbling like a cracker. More like melted chocolate. Bending slowly into shape. You remember Play-Doh as a kid. Hard at room temperature, but warm it up and it shapes easily. This rock sits at that same tipping point. Scientists found once rock passes 300 degrees, under enough pressure, it behaves completely differently. Atomic bonds start to loosen. Not fully broken, but enough that under sustained pressure, rock slowly deforms. This deformation is incredibly slow, maybe centimeters a year. But over millions of years, it shifts mountain ranges thousands of kilometers, 40,000 meters to 40 kilometers down. You've broken through the crust. Everything opens up. You've entered the top of the mantle. Temperature jumps to 1,000 degrees. The rock glows dark red. And now it's truly flowing, like magma in extreme slow motion. Creeping along. Geologists call this the 100 to 200 kilometers deep, the most active part of the mantle. You reach out and feel it. This rock is mostly a green gemstone on the surface. But at over 1,000 degrees and huge pressure, it turns semi-solid and flows. Think of honey in the fridge. It thickens up, barely moving. Mantle rock behaves the same way, still solid. But on a geological time, it flows ever so slowly. The flow carries you downward, about 10 centimeters an hour. What's the point? That's slow. But you do the math. That's 88 meters a year, 880 kilometers in 10,000 years, 88 million in 100 million years. This slow-moving rock, over tens of millions of years, pushed the Indian plate north, colliding to raise the Himalayas. Now you understand mantle convection. Just like boiling water. Water at the bottom heats up. Hot water rises. Cold water sinks, forming a cycle. Earth works the same way. The core is 6,000 degrees, like a giant furnace, heating the mantle above it. Hot mantle rises, reaches the crust, loses its heat, cools, and sinks back down. This cycle has run for 4.5 billion years, driving continental drift, triggering quakes and eruptions. 200,000 meters to 200 kilometers down, deep into the mantle now, 1,800 degrees, 150,000 atmospheres, an orange-red world surrounds you, shifting like a giant slab of jelly. You feel your own body start to deform under the pressure. Your bones crack and pop. You look around. Most of this is still solid rock, but the heat and pressure let it creep like a slow liquid. Olivine makes up 60% of the mantle. The rest is pyroxene and garnet minerals. Suddenly, you spot blue crystals glowing in the rock. You pry off a piece. It's scorching hot, but you feel its strange structure. It's called ring, a mineral that only exists 410 to 660 kilometers down. In 2014, scientists found a diamond in Brazil, with a tiny fragment of it inside. Back in the lab, they tested it. Stunned, 1.5% of it was water. Water has hydrogen and oxygen locked in the crystal. Just like ice traps, water molecules, you do the math. The mantle is 84% of Earth's volume. At 1.5% water content, the water hidden in the mantle could be 3 to 5 times all the oceans, meaning the Pacific, the Atlantic, the Indian, and Arctic combined hold less water than this rock beneath you. Where did this water come from? Maybe when Earth first formed, meteorites brought water sealed into minerals, or seawater, dragged down by subduction, slowly sank into the mantle, building up over eons. This water won't stay locked forever. When volcanoes erupt, some escapes with the magma, turning into vapor, eventually falling as rain. The water you drink today may have sat in the mantle eons ago. 1 million meters to 1,000 kilometers down, you've reached the mid, about 2,000 degrees. Now, you see black rivers cutting through the rock. Liquid iron, where did it come from? 4.5 billion years ago, meteorites collided to form Earth. The whole planet was molten then. Over 2,000 degrees, iron is dense, 7.8 tons per cubic meter, heavier than rock, so it slowly sank. Over tens of millions of years, most sank to the center, forming the core, but some never made it down. Trapped in the mantle instead, heat melts it into liquid, flowing toward the core. Earth swallows millions of tons a year, bit by bit, feeding the core. 2,890,000 meters to 2,890 kilometers deep, the bottom of the mantle. Below is the outer core. Boom. You suddenly plummet faster, breaking through the boundary. 2,500 degrees spikes to over 4,000. You nearly black out. Coming to, you look around. A golden ocean stretches before you. Not rock, liquid metal. Pure molten iron. You feel something strange. Your body feels lighter. Not weightless exactly, but gravity clearly weaker. That's because the mantle above pulls you up. The core below pulls you down. The two forces nearly cancel out. You feel weightless. You float in this sea of iron, feeling it flow around you. It moves fast, 15 to 40 kilometers an hour. This sea is 7,000 kilometers across, an almost unimaginable weight, 32% of Earth's total mass. You pull a compass from your pocket. The needle spins wildly. Suddenly, it clicks. This iron sea makes Earth's magnetic field. You remember physics class. The teacher spun a coil near a magnet, and the bulb lit up. The teacher said, a moving conductor creates current. This iron sea is the conductor. Liquid iron conducts. Earth's spin drives it, like a generator spinning coil. You look closer. The flow isn't random. It follows a pattern. Near the inner core, it flows east. The outer layer flows west. Some moves north-south. Every current acts like a live wire, making its own field. Countless small fields overlap, forming Earth's whole field. Even better, it's a self-sustaining loop. Flowing iron makes current. Current makes field. The field shapes the flow, which strengthens current again. And current strengthens field, like a perpetual motion machine, running 4.5 billion years, never stopping. You watch the compass spin. What if there were no field at all? The sun blasts 1 million tons of particles a second, 300 to 800 kilometers per second, millions of degrees hot. It's called solar wind. If it hit Earth directly, it would strip the atmosphere away. But Earth's field blocks it 60,000 kilometers out. An invisible shield, channeling it toward the poles. Those particles slam polar air and glow green. The aurora, you think of Mars, 6,779 kilometers across, half the size of Earth. Its core is too small, cooling fast. It solidified 4 billion years ago. No liquid iron flowing, no current, no magnetic field. Solar wind hits Mars head-on, stripping its atmosphere over each. Mars air pressure is 0.6% of Earth's surface temperature, -60. Dead silence. 5,150,000 meters to 5,150 kilometers down. With your last strength, you look down. A massive golden sphere hangs before you. The inner core is 2,440 kilometers across, smaller than the moon's 3,474, 5,500 to 6,000 degrees, hot as the sun's surface. This has to be liquid iron, you think? Iron melts at 1,530. How is this solid at 6,000? But you get closer, reach out and touch it. Rock hard. A solid iron sphere. You check your pressure, 3.3 million atmospheres. Suddenly, you understand. Under pressure, this extreme, iron atoms are crushed together. Unable to move, locked in place. No matter how hot, the pressure is too great. It has no choice but to stay solid, like a packed subway at rush hour. You can barely lift an arm. You feel out this sphere. Density, 13 tons per cubic meter, 1.7 times denser than surface iron. Shape, inner core, iron, into a 1 meter cube. It weighs 13 tons, as heavy as 2 elephants. Even stranger, this sphere spins on its own, faster than Earth itself. 0.3 to 0.5 degrees extra each year. Every 900 to 1,200 years, one full extra spin. Why does this happen? You pay closer attention. Molten iron flows fast outside, dragging the sphere along, like a current spinning a ping-pong ball, but the ball has its own inertia, a different speed than the flow. The inner core is that ball. The outer core is the current. In 1996, 2 Columbia scientists analyzed 30 years of seismic data and found the time waves take to cross the core shifts subtly year by year. After repeated calculations, a startling conclusion: the inner core spins faster than Earth. Published in Nature. Stunning the world. You stare at this golden sphere, and with your last strength, smile. Humans reached the moon, 380,000 kilometers away, 6 times. Mars, 400 million kilometers at its farthest. Dozens of probes sent there, but the core, just 6,371 kilometers down, closer than a flight to New York. Yet no human has ever been here. The deepest hole ever dug is the Soviet Kola Super Deep. Started in 1970, drilled for 24 years, wore through dozens of drill bits, cost hundreds of millions. It stopped at 12,262 meters. Why stop? At 180 degrees, the drill bit softened and gave out. Not even 0.2% of Earth's radius. Like poking a toothpick hole in a watermelon. Your mind starts to fade. But you think, this iron sea has flowed for 4.5 billion years, creating the magnetic field, blocking the solar wind, protecting the atmosphere, making the oceans possible, and life, and humanity. Suddenly your eyes snap open. You're in bed, drenched in sweat. Sunlight streams through the window. The clock reads 7:30 a.m. It was all a dream. But you glance at the book by your bed. Its cover showing crust, mantle, outer core, and inner core. You smile, even though humans may never reach Earth's core. The knowledge we have is real. Exploration never ends. That's what makes humanity amazing.